Welcome back to my YouTube channel for the another video. In this video, we'll discuss about another graph traversal technique. So this is called as BFS breadth first search technique for the graph. So see that what is BFS? BFS traversal of the graph produces a spanning tree as a final result. Spanning tree is a graph without loops. We use a Q data structure with maximum size of total number of vertices in the graph to implement BFS traversal. Now we'll talk about that graph traversal technique. So here that this is one of the graph traversal technique. There are two graph traversal technique. One is DFS, that is depth first search, and one is BFS. This is called as breadth first search. DFS is based on stack and the BFS is based on the queue. So here that queue means that first come first served. So if any element will be inserted first, will be deleted first from the graph. So again you have to check the number of vertices and accordingly you have to check the queue, right? Now see the steps here. Step number 1, define the queue of size, total number of vertices in the graph. So again you have to see the number of vertices and according to the number of vertices you have to define the queue. Step number 2, select any vertex as a starting point of the traversal. So you have to choose any one of them as a source vertex and from there you have to traverse with the other vertices. Visit that vertex and insert it into the queue. So that means whenever you are visiting the vertex, that vertex will be added to the queue. Step number 3, visit all the non-visited adjacent vertices of the vertex which is at front of the queue and insert them into the queue. So all the adjacent vertices from the source vertex will be added to the queue. Step number 4, when there is no new vertex to be visited from the vertex or you can say the source vertex which is at the front का मतलब होता है from the beginning of the queue, then it will be deleted from the vertex. So that means you have to see all the adjacent vertices. If all the adjacent vertices are traversed, then you have to leave that particular vertex, and whenever you leave the particular vertex, that will be removed from the queue. Step number 5, repeat step number 3 and 4 until the queue becomes empty. So here you can see that step number 3, we are visiting all the adjacent vertices. Once you visit the adjacent vertices, you have to leave the particular vertex. Whenever you leave the particular vertex, that vertex will be removed from the queue. So step number 6 here, when queue becomes empty, then produce final spanning tree by removing unused edges from the graph. So this is all about your BFS. These are the steps. Now you can see through the example. See the example here, we are considering the BFS graph and having the number of vertices are 7 here, A, B, C, D, E, F and G. Out of these number of vertices, you have to choose one of the vertex as a source vertex. So you can see the A is a source vertex here for this particular graph. Select the vertex A as a starting point. So we'll visit A and we'll insert that particular vertex into the queue, right? So we are inserting this A here in the queue, right? So that A is added to the queue. One more thing, there are 3 coloring schemes in the BFS. When all the vertices are non-visited, all the vertices will be in the white color. As you can see in the previous diagram, all the vertices are in white color when they are non-visited. So once you visit, any vertex will become gray color, and as soon as you leave the particular vertex will become black color. So you have to think about all the 3 coloring schemes. One is white color, one is gray color, one is black color. So when any vertex is non-visited will be a white color, when you are just visiting the vertex will become gray color, and when you are leaving the particular vertex after visiting all the adjacent vertices will become the black color. Now see the step number 2, you will have all the adjacent vertices from this A. So visit all the adjacent vertices of A which are non-visited. So see that from A, non-visited vertices are this B, D and E. So you have to visit all the 3 vertices which are adjacent to particular vertex, right? So these are the 3 vertices D, E and B. So all the 3 vertices will be added to the particular Q. Okay, one more thing, once you visit all the vertices, now this vertex will become, you have to leave this particular vertex because there is no any other vertex which are non-visited. So that vertex will be removed from this particular vertex, particular Q, right? So insert newly visited vertex into the Q and delete A from the Q. So see that all the non-visited vertices are added to the Q, right? And after that, this is the source vertex. Now this will be removed from this Q. So now you can see this table. A is removed. Why? Because A is already visited, right? And all the adjacent vertices are also visited. So new vertices are added to the Q and the old vertices are removed from the Q. Then in the next step, you have to remove one by one because you are selecting the next vertex, you are selecting the next vertex, you are selecting the next vertex. So visit all the adjacent vertices of D, right? So all the adjacent vertices of D, right? So D के adjacent क्या क्या यहाँ पे A and E, right? So you have to visit this A. A is already removed. Now you have to remove this D. Why? Because you are going to the next vertex. So this D will be removed from this particular Q. The next vertex is which is newly adjacent. So next vertex is from this particular vertex E. E के adjacent क्या क्या यहाँ पे C and F. So these are the vertices which are added to the graph, right? So C and F will be added to the particular Q. So B is already there. Now you have to add the new vertices here C and F. Now this E will also be removed from the particular Q, right? Now the remaining vertices, because from here you have to visit the next vertices, so this B will also be removed from this particular Q. So B will be removed here. Now these are C and F are remaining. So next you have to visit the vertex, so that B will be removed from this particular Q. Then these are the 2 vertices which are remaining, that C and F here. So visit all the adjacent vertices of B which are not visited. So there is no any vertex. So B के जो भी adjacent vertices है, all the vertices are non-visited, right? So, but for this case you can see that all the vertices are visited here, there is no any vertex remaining. So we'll remove this B from the Q. So next these 2 vertices C and F are here, right? So you have to check the next vertex, that is G, so that G will be added to the graph. Okay, so that G will be added to this particular Q. Now this, when you are adding the G, that C will be removed because the source is that C here, right? So whenever you are choosing the next source vertex, that will be removed from the Q. So this G will be this C will be removed. Then you have to come back. So right, this the next vertex will be removed from the Q is that F, and finally with this G will be removed. So this is all about your BFS visit. So here you can see that visit all the adjacent vertices of G which are non-visited. So you can see that C and F all are adjacent vertices from G, but there is no any vertex which are non-visited. So we will delete G from the Q, right? Now this Q will become empty here. Q will become empty here. Now, so final result will be, right? So final result will be become a spanning tree. Okay, thank you.